My dear friends, right now the question paper which we are solving, that is October-November 2025, paper 4, variant 1. Time allowed, of course, 1 hour 15 minutes, which means in terms of minutes it is 75 minutes paper. And marks are how many? Marks are 80. So less than a minute per mark. And value of g, again and again I'm telling, that is equal to 9.8 meters per second square. So let's start without any delay. Question starts from here. A train travels with a constant velocity of 56 meters per second on a horizontal track. On what? On a horizontal track. So what we are supposed to do, the mass of the train is this 440,000 kilograms. So mass is given. State the difference between velocity of the train and its speed. It's very simple, common answer. I will be writing V for velocity and V for vector. It is only one mark. So velocity is a vector and speed is a scalar quantity. For one mark, that is more than enough. Even you can say that velocity of the train is 56 meters per second in a particular direction, whereas speed of the train is simply 56 meters per second. Even that one will also work. Even that one will also work. Now calculate the kinetic energy stored in the moving train. So very simple, dear friends. Just we need to put the equation values into the equation. 1 over 2 mv square. So 1 over 2 times mass is how much? Mass is 440,000 kilogram times speed is already given 56. But don't forget to take the square of this. So dear friends, I'm writing the answers after rounding off. So this is 690. After rounding off 690, then 0, 0, 0, again 0, 0, 0. So it means we can write it is 6.9 times 10 raised to the power of 8. So even we can write this one as 6.9 times 10 raised to the power of 8, and it is kinetic energy, so in joules. So you can calculate. I have just written the answer after rounding off. The train has a uniform deceleration of this. That means acceleration. Calculate the constant braking force which brings the train to rest. Which brings the train to rest. Braking force which brings the train to rest. So simple and straightforward. What can we do? F is equal to ma. F is equal to what? ma. So mass is there. How much is the mass? 440,000. It is given in the first line. And acceleration, he gave himself 1.2. That is deceleration, but no need to worry about that. We are talking about the magnitudes. So dear friends, 440,000 times 1.2, and we are getting 52,528,000. It is 528,000. So I can write it 5.3 times 10 raised to power 1, 2, 3, 4, 5. 5, and it will be not joules, it is a force. So dear friends, it will be equal to simply Newton. Don't forget to write the correct unit with the final answer. Now calculate the distance traveled by the train as it comes to rest. Distance traveled by the train as it comes to rest. Now, my dear friends, we know one thing, that work done is equal to energy transferred. Work done is equal to energy transferred. This is very common question. Sometimes they are asking, mostly they are asking for the distance before the body is coming to rest. So I can write it work done. So I will be writing simply W dot D. Now here, work done, force times distance, and which energy basically? Energy transferred, work is done, and kinetic energy is there because the train is moving. So, dear friends, force we just calculated. We have just calculated it is 5.3 times 10 raised to the power 5 times D, and kinetic energy we have calculated in the beginning. So that is 6.9 times 10 raised to power 8, 6.9 times 10 raised to the power of 8. So when we simplify for D, that will be equal to 6.9 times 10 raised to power 8 over 5.3 times 10 raised to the power of 5. So as we simplify, answer comes to be 6.9 times 10 raised to the power 8 over 5.3 times 10 raised to the power of 5, and as I'm calculating roughly, my dear friends, I'm getting answer 1.3. It is 1300 almost, so 1.3 kilometers. 1 point, no wait, my calculator has done something wrong. Wait a minute. Ahmed has, you be quiet, Ahmed. You don't bring, how to bring the formula, just wait a minute. First let me calculate. The sleeping attitude will not work. Very straightforward formula. But wait, first let me calculate. 6.9 times 10 raised to the power of 8 over 5.3 times 10 raised to the power of 5. As I'm simplifying, I'm getting, 1301. So instead of writing directly the answer, first of all, my dear friends, 1301, this is in meters. So you can write here even 1300 meters, or you can write 1.3 kilometer, that will also work. Now, braking force. Work done is equal to energy transferred. How work done is equal to energy transferred? If you are pushing a car, so you are applying the force and car is covering the distance. It means work is done. Work is done on the car. And what that work is done is doing, it is converted into energy transferred to the car. And what happens to the car? Car starts to move. Any body moving, it has which energy? It has kinetic energy. Now in this whole question's scenario, we started with that there is a train, moving at the speed of 56 meters per second on a horizontal track. The mass of the train, 440,000 kilogram. Then they ask the difference between speed and velocity. So quite simple. Velocity is a vector and speed is a scalar quantity. So straightforward answer. Calculate the kinetic energy stored in the moving train. So kinetic energy 1 over 2 mv square. We have mass, we have speed. As I simplified and rounded off according to the mark scheme directly, so it is 6.9 times 10 raised to power 8 joules. Now, the train has a uniform deceleration, so it means car is going to be on rest. It is going to be coming on rest. So calculate the constant braking force on this. Braking force will be the retarding force. So F is equal to ma. So retardation, deceleration is a type of acceleration. I did not use minus sign, no need, because we are calculating the magnitude. So 440,000 is the mass and times 1.2. So we got this, and I have rounded it off to this number. Now, my dear friends, the next question is calculate the distance traveled by the train as it comes to rest. Before coming to rest, train is moving. So when you are applying the brake, force is applied and distance is moved. So it means work is done. So work done is equal to energy transferred. As I gave you an example, even you are lifting a small mass upward. You are doing work on the mass. Why? Because you are applying the force equal to the weight of the body and it is covering a distance. So work is done. And what that work is done being stored, it is as energy transferred. Which energy transferred? Body is moving upward. So it's gaining height. So it means gravitational potential energy. That is a separate case. In this case, it is motion. So when work is done, energy is transferred. So work is done, F times D. Energy transferred in this case because it is involved in motion. So 1 over 2 mv square. Then simply placing the values and making D as the subject of equation. And we are getting the answer. Either you can write 1300 meters or 1.3 kilometers. Now, let's move to the next question. Table 2.1 contains information about the planet Mars. Planet Mars. Mass of the Mars is given. Gravitational field strength on the Mars is given. Average density is given. Define gravitational field strength. Even gravitational field strength, and I told you, especially the students who are going for exams, check the unit. Gravitational field strength is Newton per kilogram. It means force on unit mass. It means what? Newton is the unit of force. So what is gravitational field strength? It is force per unit mass, because Newton per kilogram, force per unit mass on what? On an object where? In a gravitational field. And gravitational field is caused by a mass. In a gravitational field. And I think if you just write force per unit mass, it will also give you 1 mark, as this is only 1 mark. Force per unit mass, that is also a number. Just little bit explanation. Newton per kilogram. Newton is force. Newton is what? Force. And kilogram is mass. So force per unit mass on an object which is in a gravitational field. Or this is from so simple. An object has a weight of 42 Newton on the surface of Earth. This is WE. Calculate the weight of the object on the surface of the Mars. Surface of the Mars. So weight on the surface of the Mars, that will be equal to mgm. Gm is with us. Mass is question mark, but we can get the mass. How? Weight on Earth, my dear friends, that is equal to mge. So weight on Earth is how much? 42. Mass we need to find, and value of G 3.7. Am I right? No, I'm not right. And you people are just sleeping. Value of G on Earth, it is 9.8. So mass will be equal to 42 over 9.8. And when I'm calculating the mass, that comes to be 42 divided by 9.8, and that becomes equal to be 4.28. So 4.28, so we can use it 4.3 kilogram. Okay, now weight on Mars. Mass is a constant quantity. Wherever the object you are taking in the universe, same object will be having the same mass. So this will be equal to 3.7, because value of G on Mars, that is 3.7. So multiply them times 3.7. We are getting the answer 15.85. 15.85. We can write 15.9. Even you can round it off to 16. That will work even. No problem at all. So 15.9 Newton will work, or you can write even 16 Newton. Okay, my dear. So this was for 2 marks. Anybody having any question here? Feel free, you can ask me. What is the approach? This is very common MCQs also nowadays. What is the approach? We know mass of an object, it stays constant throughout the universe. Mass of an object stays constant throughout the universe. So weight on the Earth was given. So easily we can calculate the mass of the object on Earth. If mass of the object on Earth can be calculated, same mass for the same object in any place in the universe. So Mars gravitational field strength is given. So simply we can use that mass to get the answer. Now, my dear friends, let's move for calculate the volume of the Mars. Now see, we have the mass already and density is given, I think. Density is given, see, average density. So easy to calculate the volume. So we know density is equal to mass per unit volume. So volume will be equal to mass over density, volume of the Mars. So volume of the Mars mass, which is 6.4 times 10 to the power 23. It is only 10 times smaller than Earth. 6.4 times 10 raised to power 23, because the mass of the Earth is 6.4 times 10 raised to power 24 over density. Density of the average density on the surface of the Mars is 3900 kilogram. So divided by 3900, dear friends. Some students asked me to solve paper 4, so I started solving paper 4 today. Now, my dear, next class we will either solve paper 2 or paper 6 tomorrow 1:30, but I will let you know. So 6.4 times 10 raised to the power of 23 over 3900, and when we are simplifying we are getting 1.64 times 10 raised to power 20. So this answer comes to be 1.64 times 10 raised to the power 20. So simply I can write two significant figures, 1.6 times 10 raised to power 20, but unit will be meter cube. The reason for that, see, the density was kilogram per meter cube and mass was kilogram. So kilogram will be cancelled with kilogram, but system international units are in action. So answer is 1.6 times 10 raised to power 20 meter cube. Please, anybody having any question here, feel free. You can ask me. Lesson is being recorded. It will be shared with you also at the end of the lesson when it will be converted into the proper MP format. So you can even rewatch it. Now, next is figure shows a space buggy that is tested on Earth. The buggy is traveling at a constant speed in a straight line. It means constant speed in a straight line. It means acceleration is 0 because velocity is not changing, constant. The driving force on the buggy is 30 Newton. Draw and label one arrow on figure 2.1 to show the size of the direction of the resistive forces on the buggy. Resistive forces on the buggy. One thing is very important here. My dear friends, as it is moving at constant velocity, you know what will happen? Resultant force will be 0. So 30 Newton is the forward force. My dear friends, same length almost arrow. So resistive force, which can be friction, air resistance, whatever. Resistive force, and that is also how much? 30 Newton. Show the size and direction. So size and direction, you have to tell 30, and direction, arrow in opposite direction. 2 marks. Okay, why 30 Newton? Because already it is mentioned here, the buggy is traveling at a constant speed in the straight line. It means velocity is not changing. It is going with constant velocity. It means acceleration is 0. So when acceleration is 0, it means the resultant force on the buggy, it should also be 0, so that acceleration is equal to 0. And acceleration 0 means resultant velocity, velocity is constant. Be very careful. Air resistance on the Mars is less than the air resistance on Earth. The same driving force, 30 Newton, is exerted on the buggy on the Mars. State the effect of this on the resultant force on the buggy on the Mars. So resultant force on the buggy on the Mars will increase because forward force is still 30 Newton, but this one will decrease. As it is mentioned, air resistance on the Mars is less. So resultant force, state the effect on the resultant force, we will say resultant force increases. Simply what will we write? We can write resultant force increases. Why? Right now on Earth, the resultant force is 0 Newton. That's why it is not accelerating. But it is mentioned very clearly that air resistance on Mars is less than the air resistance on Earth. It means, and forward force is still constant, so it means backward force will be reduced from 30, maybe it will become 20, 25, 22. So 30 minus 22, it means 8 Newton resultant force is acting on surface of the Mars on this buggy as compared to on Earth where it is a resultant force equal to 0. So resultant force increases. State the relationship between the resultant force, driving force, and resultant force. So, my dear friends, I will be writing it, starting to write from here. The resultant force is equal to, of course, driving force minus resistive force. If any one of you having any question here, please feel free. So this question is also completed and it was for 8 marks, my dear friends. Anybody having any question, any query, please feel free. You can ask me now. And sit with Sabr because this class will of course go long, paper 4, and we have to complete it. Okay, now let's move forward. What is the next question? That is on solar panels or something like that. And 2 marks are there. Figure shows a simplified diagram of a solar cell. Solar cell is used to convert light energy into electrical energy. So there is black coating. There is light falling on these plates. Negative contact is there. Voltmeter is there, conducting material in solar cell. Describe the energy transfer in the solar cell. Even I answered it in the beginning of the question. In the start of the question. So light energy from sun to electrical energy. Light energy from the sun to what? To electrical energy. Or better, we can write light energy from the sun produces electrical energy. Better. Produces electrical energy. That's okay. Suggest how the black coating allows the solar cell to transfer more energy. Now, this is thermal physics also involved in question number 3. Black bodies are very good absorbers of radiations. So, black coating, or we can say black body or black color. Only 1 mark, no need to go a lot of detail. Black coating is a good observer. Black coating is a good observer. That is enough for 1 mark. Now come here. Next question. 0.72 kilowatt. It means 0.72 times 10 raised to power 3 of light is incident on the solar cell in figure 3.1 here. The cell has an efficiency of 75%. Calculate the output power of the cell and how many marks? 2 marks. So we can write the efficiency in percentage. So efficiency formula is percentage efficiency formula is useful output energy, not energy, it will be power because already power is given. Useful output power over total input power times 100%. Now, my dear friends, what is the efficiency? That is 75% equal to useful output power. I'm writing PO over total input power. That is 0.72 times 1000. Why? It is kilowatt. And times what? 100%. So my dear friend, percent is cancelled with the percent. So it means power is equal to, okay, these two zeros are cancelled with these two zeros. So power is equal to 75 times 7.2. You can use calculator easily. You can get the answer. It no need to do the way I'm doing, like 1000 and 100, two zeros cancel with two zeros. Even you can do in your way. 7.75 times 7.2. Answer is 540. Output power is 540 watt. As input is in kilowatt, so we can also write the answer in kilowatt. This implies that either you can write here 540 watt or 0.54 kilowatt. Why? Because, my dear friends, to convert from watts to kilowatt, we need to divide by 1000. So 540 divided by 1000, it will be equal to 0.54 kilowatt. Okay, so 0.54 kilowatt. Kilowatt. State the meaning of term kilowatt hour. Kilowatt hour is the unit of energy. First of all, it should be in your mind. It is electrical energy transferred. Electrical energy. Kilowatt hour. So this is energy. It is electrical energy transferred by 1 kilowatt appliance, electrical appliance. 1 kilowatt appliance in how much time? In 1 hour. That's what kilowatt hour mean. Any electric, like electric iron, it is turned on for 1 hour, but the power of the electric iron is 1 kilowatt. So whatever the energy it will consume, that will be 1 kilowatt hour. So you can write it in your own words, but the meaning should be same. So electrical energy transferred by 1 kilowatt appliance like an electric iron in 1 hour. Okay. Now next is, this is a bit tricky. Energy is produced by each solar cell for an average of 6 hours per day. A household uses approximately 7,400 kilowatt hour of electrical energy every year per year. Calculate the number of solar cells needed to produce energy for one household. Give your answer as a whole number of solar cells. Okay, no problem. Let's calculate. First of all, total output power which is required. Okay. So my dear, first of all, let's see. We can calculate total. First, let me write and explain, then I will complete, and then I will be total output power needed in 1 year. That will be equal to that we can do 7,400 it is in kilowatt, divided by 365 days, and every day how much? 6 hours it is used. How much it is used? 6 hours it is used. My dear friends, answer comes to be 7400 divided by 365, 6, and I'm getting 3.378. So how much output power I'm getting? 3.378. 8 watt. This is per day. Basically, this is per day. So how many solar cells are needed? That's what. Let me round it off to. Wait a minute, my dear friends. I can round it off to 3.38. 3.38 watts. Sorry, kilowatt hour. This is in one day. So how many solar cells are needed? So my dear, already we know one cell can produce how much output? That is 0.54. So if I'm making like 3 divided by 0.54. Okay, now number of solar cells, that will be equal to 3.38 over one cell has 0.54 kilowatt average. And as I'm dividing it, I'm getting 6.257 number of cells. And answer here will be 7 cells. Reason they said as a whole number. So 6.25. This is not rounding off story. Actually, they said whole number. If I'm taking 6 cells, we cannot get the required amount of energy. So it should be more than 6. That is 6.25. They said answer should be whole number. Answer should be what? Whole number. So what I'm doing, it is answer coming 6.257. I'm writing the number of cells 7. But now let me explain you what is going to happen. Energy produced by each solar cell for an average of 6 hours per day. So for 6 hours, you can say every 24 hours, a solar cell is producing the energy. A household uses approximately 7,400 kilowatt of energy per year. Calculate the number of solar cells needed to produce energy for one household. Give your answer as a whole number. Now, first of all, we need total output power needed per day. Per day we are taking. So, no, that is not power. Sorry. Total output energy, my dear friends. This is not power. Because kilowatt hour we are calculating. This is total output energy. Because kilowatt hour. So needed 7,400 per year. And every year, how many days? 365 days. And how much time per day it is working? 6 hours. So we are getting that 3.38 kilowatt hour energy is needed per day. So number of cells, see, we have calculated already that output power of the cell is 0.54 kilowatt. So that's why 0.54 kilowatt hour. We will divide this total energy by 0.54. Answer comes to be 6.257. 6.257. They said number of the cells, solar cells in whole number. 6 I cannot write because then the production will be less than required. So we can go to the next whole number, that is 7. So that's why number of solar cells we will use, it will be equal to 7. Okay, so this is about the number of solar cells needed, and basically this is energy as well as thermal altogether questions. Okay, one or two things about thermal, but rest is work, energy, and power. Now let's move forward, and that is particular question of thermal physics. Now, a 12 volt and 50 watt, 12 volt, 50 watt immersion heater. So this is V, and this is power. is used to heat 0.5 kilogram of water, 1.5 kilogram of water in a beaker. The water is initially at room temperature, so this we can say T1. The specific heat capacity of water is this. Calculate the energy supplied. E we need to calculate to raise the temperature of the water from this to this. So it means this will help us to get delta T. So this is straightforward, very simple question. Energy is equal to mc delta T. Mass is there. How much? 0.15. C is there. That is 4200. Change in temperature, that is from 58 to 20. Let's simplify it and see the answer. 0.15 times 4200 times bracket 58 minus 20 bracket close. When I'm doing it, 23,940. 23,940. So I can round it off to 24,000. So this way, or we can write 2.4 times 10 raised to power 4 joules. Okay, this was straightforward. Here it's bit important and you have to be very careful. The immersion heater is removed from the beaker. Heater is no more into the beaker, it is taken out. One metal rod and one plastic rod are placed in the beaker of hot water as shown in figure. See, one plastic rod, one metal rod, they are placed into the hot water as shown in figure. The rods are at room temperature 20 degrees Celsius before they are placed into the heater. So initially they are at the same temperature. And both are at, before they are put into the hot water, both of them are at what temperature? They are at 20 degrees Celsius. Okay. And see, there is describe how the temperature of the point X. See, X is marked here, X is marked here, and point X is 2 centimeter from the end of the rod. Maybe from here. Or maybe from here, but I think it should be here. Anyhow, so they are at the same distance from one end. So describe how the temperature of point X on each rod changes after the rods are placed in the beaker. Explain your answer. 4 marks. Wow. So first of all, see, both are rods, solids. And we know in solids, heat is majorly transferred by conduction. Okay. And also metal rod, it is having free electrons. They move through the metal to transfer the energy. Then metal is a good conductor. So the temperature, and they said, they did not say heat, they said temperature upon. So temperature of the metal rod, point X of the metal rod will increase faster. While the, as it is, I told you the explanation, while the temperature of the plastic rod will increase, but with time or slowly. So in this way, 3 to 4 marks we can score. So let's start writing the answer. And if anybody of you is having a problem when I'm writing the answer, read it. Otherwise, you can ask me, I can re-explain it. First of all, the very important thing is that the heat will be transferred by conduction. Thermal energy is transferred by conduction. Now, second mark will be temperature of point X. Temperature of point X in metal rod increases quickly as Metal has free electrons, free or delocalized electrons moving through the rod. Yeah, flowing, you can say, flowing through metal rod. I think 3 marks you have scored. Now the final mark, and we can say temperature. Don't write here, but just I'm writing now. So temperature of point X in plastic rod increases slowly as plastic has no free electrons. I think that is more than enough, my dear friends. And if there is any question or query, please feel free. You can ask me. Read the question carefully and wait a minute. Let me bring the question in this whole scenario in one frame. And now you can read the question. Question I can read for you. One metal rod is one metal rod and one plastic rod are placed in the beaker of the hot water as shown in figure 4.1. The rods are at the room temperature before they are placed into the beaker, so they were at the same temperature. Point X is marked, which is at the same distance 2 centimeters from the end of the rod. Explain how the temperature of point X on each rod, metal rod and plastic rod, changes after the rods are placed in the beaker. Explain your answer. First of all, in this case, energy is transferred by thermal conduction. 1 mark. Then temperature of the point X in metal rod increases quickly as, this is 2 mark. Reason now, as metal has free electrons moving through the metal rod, or you can say it has free electrons carrying the energy from hot end to the cold end, that will also work. On the other hand, temperature of point X in plastic rod increases but slowly as plastic has no free electrons. So in this way, you have well explained it for 4 marks. Anybody having any doubt, any query, feel free, you can ask me. But in the meanwhile, I will be moving to the next question. Now see, a dolphin communicate with other dolphins underwater by emitting sounds in the range of 7 to 15 kilohertz. Okay. State the value of the speed of sound in air and state how the speed of sound in water differs from the speed of sound in air. So speed of sound in air, that is 330 meters per second. We can take speed of sound in water roughly on the average a 1500. Now see here meter per second is given, but here it's not given. You have to write. Be very careful. State and explain if humans with normal hearing can hear all the sounds emitted by the dolphin. Yes. The reason, it is from 7,000 to 15,000 kilohertz. And you know, for humans, their hearing range is from 20 to 20,000 hertz. So this is within the range. So yes, 7,000 to 15,000 hertz frequencies are within normal within normal hearing range for humans, or in any other words with the same meaning. Very simple question. Now come, complete the table 5.1 to describe the differences in loudness and pitch of two different dolphin sounds. Complete, okay, frequency in kilohertz 14, amplitude large, so loudness will be high. Yeah, higher. Pitch, because frequency is higher, so pitch will also be high. Yeah, you can write higher. When frequency becomes 8 hertz, so pitch will become lower, of course, and pitch will become low and amplitude is low. So low sound or quiet sound, you can say QUIET, quiet. Loudness, here you can say loud sound better, and here you can say quiet sound or soft sound. QUIET, quiet sound. That is simple. Why so? Because loudness, let me write it. Because loudness of sound is directly proportional to amplitude of the vibrating body. I'm not writing complete, but just like this. Loudness is directly proportional to amplitude. If the amplitude is large, sound will be loud. Amplitude small, sound will be less loud or quiet. Similarly, pitch is directly proportional to frequency. Okay, so low frequency, low pitch, high frequency, high pitch. And also let me tell you one thing more, that dear friends, this pitch is also inversely proportional to wavelength also, because for same sound, for same speed of sound, wavelength and frequency are reciprocal to each other, mean inversely proportional to each other. If the wavelength is more, frequency will be less and vice versa. So anyhow, these were the clues for this answer. Complete these sentences to describe how the sound is transmitted through the water. So sound waves are made up of vibrating particles which produce compressions and rarefaction. A compression is a region of, just recall memory, a region of high pressure, and rarefaction is a region of low pressure. The sound wave travels blank to the direction of the vibration. We know that is sound wave is longitudinal. So this is parallel or same direction to the direction of the vibration, or even direction of energy transfer also sometimes you can find in questions. Sometimes you can get, they will say direction of energy transfer. Sound wave is a longitudinal wave. So here the direction of the vibration is parallel to the direction of the sound wave or energy transfer. Okay, so this is done. Next, my dear friends, figure 6.1 shows part of an optical fiber used in high-speed broadband communication. High-speed broadband communication. State two advantages of using optical fiber in high-speed data transmission compared to electrical signals sent on copper wires. First of all, this is some sort of recall memory. They are very secure. Okay, high-speed data transmission, this is secure, and even lighter, you can say. Many are there in this. Data is not lost, or very small data is lost. So 2 marks, these 2 points are enough. Okay, next is the optical fiber is made up of glass with refractive index of 1.4. N is given. Calculate the critical angle. There are three formulas, and one of them we will be using here. One of the critical formula for refractive index is N is equal to 1 over sine critical angle. Now cross multiply, you will get sine critical angle is equal to 1 over N. Then, my dear friends, critical angle will be equal to sine inverse 1 over n. Then you can write sine inverse 1 over 1.4. So when I'm calculating this shift sine and then 1 over 1.4, I'm getting the answer 45.58. So we cannot write in decimal. Simply you can write 46 degrees. In protractor we are using, so in protractor the least count is 1 degree. So how can we measure 45.58? Just write it 46 by rounding it off. State the meaning of critical angle. Now this is the definition, my dear friends. This is what? Definition. It is angle of incidence whose corresponding angle of refraction. Corresponding angle of refraction is 90 degrees, my dear friend. Like if this is a glass block, normal here, and if let's suppose this is the angle of incidence and angle of refraction here, my dear friends, becomes 90 degree, then this angle of incidence is basically critical angle. Mean angle of incidence in denser medium whose corresponding angle of refraction is 90 degree. That angle of incidence is critical angle. That's what is the angle of incidence. Better to write here in dense medium. In denser medium whose corresponding angle of refraction or for which the angle of refraction is 90 degree, that will be the critical angle. This was simple definition. Another thing which is very commonly asked in exams, conditions for total internal reflection to take place. Number one, the ray should be traveling from denser towards less dense. Like here, it is going from glass to air. And angle of incidence should be greater than critical angle. So as the angle of incidence will be greater than critical angle, so this will be moving back. This ray of light will be reflected back into the medium, not be going outside. Okay, so I'm sure this is okay with everybody. Now let's move forward. What is there? On figure 6.1, label the angle of incidence of the ray of light as it hits the wall of the glass fiber. Draw the continuation of the line until it leaves the. So it will suffer from total internal reflection. Come back here. And many times I told you, easiest way is if this length is given, like from here till here, now it is hitting the bottom side. If it is like 4 centimeters, I'm just assuming. This length is 4 centimeter, then 4 centimeter almost here. Okay. Upper side, then it will reflect, total internally reflect downward up to here, let's suppose, and then it will go out. Something like this you can draw. So everywhere, keep the length same, 4 centimeter, 4 centimeter, 4 centimeter. And what the concept I'm using, in mathematics, you are using isosceles triangle, a triangle which is having the same two sides equal in length. So the angles at the bases of those sides, they are also equal. Equilateral triangle, all three sides are of equal length. All three angles are equal 60, 60, 60. So if you will continue the same length within the fiber, bottom to top, top to bottom like this, total internal reflection is going on. So the angle of incidence and reflection everywhere, it will stay what? It will stay the same. By using the same rule, if lengths are equal, all three lengths sides of the triangle are equal, all three angles are also equal. So the same fashion you can go it. It's very simple. But draw the good lines, thin lines, and straight lines, not like me. I have done just roughly. Next is, my dear friends, an electricity question. Figure 7.1 shows a circuit containing a 6-volt battery of cells and three identical resistors. So it means when it is written three identical resistors, it means R1 is equal to R2, that is equal to R3. So all resistors are equal in length. So S1 and S2, S1 is closed, S2 is open. S1 is closed. The current in the emitter is 0.080 ampere. Calculate the resistance of R1. No problem. Very simple. V is equal to IR. This implies that R1 will be equal to V over I. Current is same, but 3.0 over I, which is 0.080. So when I'm calculating it, and you may be thinking, sir, voltage is 6, why you are using 3? I want you to answer it, otherwise I will be explaining. 0.08. We are getting 37.5 ohms, or you can say 38 ohms. Why so? Actually, these are in series. This is loop in series. In series, total voltage is equal to V1 plus V2. Now, if total is 6, and we know V1 is over here and V2 is over here, they are equal resistances. So they will get equal share of voltage from the battery. So 3 plus 3 is equal to 6. Now here, because we want to calculate the resistance of R1 only, so it is not having all 6. It is having only 3. Half of that 6 means 3 volts. So simplified and we got the answer. Now S1 and S2 both are closed. Calculate the reading on the emitter, show you are working. You know, emitter reading means we need to get the current. So current I is equal to V over R total. Now first please, now attentive here. R total. So my dear friends, S2 is also closed. Now R total, what to do? R1 plus R2. First of all, I will calculate the total resistance in series. So R1 plus R2, my dear friends, 37.5 plus 37.5, they are all equal. So it will be equal to 75 ohms. This is the resistance in series. But what will be the total resistance of the circuit? That will be equal to resistance in series times R3 over resistance in series plus R3, because there are only two resistances. Now I will explain you. Wait a minute. So now 75 times 37.5 over 75 plus 37.5. And answer will be, of course, less than 37.5, but let's calculate it. So 75 times 37.5 over 75 plus 37.5. We are simplifying. Answer is 25. So total resistance, my dear friends, is equal to 25 ohms. Now, first of all, let's calculate V. So total voltage, which is 6 volts over 25, as we are simplifying. So it is 6 divided by 25. Answer is 0.24. So emitter reading will be 0.24 amperes. But question is, why I'm using here now only the formula of two resistors in parallel? You know, when we will be able to calculate this resistance. So this is because here I'm calculating it. So when the resistance in series is calculated, you know what is the shape of the diagram? Positive, negative, then positive, negative. S1 and here emitter over here. Then my dear friends, here now only one resistance, which is RS, and that is how much? 75 ohm. In place of two, there is only one resistance. Then come down here and here and here. This is now R3. So that is how much? That is 37.5. Why? Because all three resistances are equal. If R1 is equal to 37.5, so it means all of them are. So now they are in parallel. That's why I use the formula for resistors in parallel, but only two resistors. So RS times R3. So we are multiplying the resistors. If there are two in parallel, we multiply them in the numerator and we add them in the denominator to get the total, and then I use the formula to get this answer. Then, my dear friends, explain in terms of work done and potential difference why there is a larger heating effect in R3 than R1. So that is simple. But here in general, mostly teachers you will find are we people can think that current produces the heating effect, so there is more current in the emitter after in the second half, so it means more heat. No, they said in terms of work done and potential difference. So my dear friends, what to do here? We will say potential difference across R3. Basically, that is 6 volt. Is larger than potential difference across R1. Potential difference across R1 that we have used already 3 volts. So, more work, more work is done to, to pass the charge from where? Through R3. Why? Because see, what is voltage? My dear friends, this is very unique question, mashallah. So voltage is equal to work done per unit charge. So if voltage is 6 volt, it means it will be 6 joules per coulomb charge. So this is so as the voltage is more, so work done is also more per unit charge. But if it is 3 volts, so it will be 3 joules per unit per coulomb charge. So that's why I have written so more work is done to pass the charge through R3 and heating effect is more. So you can rewatch the video in case of any doubt. Please feel free. You can ask me again. So figure 8.1 shows a solenoid. Another question on electricity. So this is the solenoid. Now, battery and cell is there. Draw on figure 4 complete magnetic field lines that show the pattern and direction of the magnetic field inside and outside the solenoid. 4 marks are there inside and outside the solenoid. Now, my dear friends, if I'm joining this one, so and 4 marks are there. So now what to do? Current will flow like this. See, positive towards negative. So right hand grip rule, my dear friends. Attentive. So my fingers will go in the direction of current. See the curl like this. So current. Thumb will point towards the North Pole. Thumb will point towards the North Pole. Chapter number 20, second page in the notes. So it means this side, dear friends, this side is the north, and of course this side will be then south. Okay. Now how to draw the field lines? We also know that inside a solenoid, field is strong. So lines of force will be closer. But as they come out of the solenoid, the lines are spreading because field is getting weaker. So my dear friends, what I'm going to do, see 1, 2, 3, and 4 lines. They are one thing, they are equally spaced almost to show that field is uniform. And what will be the direction of the field? That will no, but outside they will spread apart like this way, that this way, and this way. But lazim to give what? Arrow. So join them. Arrow will be always from north towards what? South, or you can give the arrows from south outward. No, they are from north to south. So my dear friends, I'm doing it wrongly. Should not be this way. So the arrows will be from north towards the south this way. Now you will score. How many marks are needed? 4. But again, first of all, we need to decide which one is north and which one is south. So right hand rule, right hand grip rule. So see, current direction I have given you. Current is going the C arrow first. This arrow in the coil, it is upward here. That is the arrow for current. Up. Curl the fingers. So this is pointing towards north. Thumb is pointing towards north. North and then south. So field lines will be always from north towards south. So arrows outward from north and into the south. Inside the solenoid, lines will be closer, equally spaced to show the field is uniform as well as strong. But as the field lines are coming out of the solenoid, they will start spreading, which is showing field is non-uniform, and also field is getting what? Weaker. And this is for how many marks? See, this is for 4 marks. So this is a bit tricky, but very simple if you know better way how to use, if you know better how to use this right hand grip rule, not Fleming's rule, right hand grip rule. Now, mark a point inside the box in figure 8.1 where the magnetic field is strong. Label this point B and explain how the diagram shows that the magnetic field is strong at B. So we can say any point, like I can say this is the point, and here I can mark with that letter B, field is strong over there. Why field is strong over there? Lines of magnetic force are closer together. So where the lines of force are closer together, field is strong. Where they are further apart, field is getting what? Weaker, only 1 mark. So arrow, any point you can give in B where the lines are closer together, here, anywhere. I just choose this point, which I have marked it B. Now, my dear friends, what is next? Yeah, this is now a relay. After a long time, this relay has come in 2025. So figure shows a solenoid in an electric circuit for a bell. Complete the circuit diagram in the figure with a symbol for a direct current power supply. Direct current power supply, so positive, negative, this is a DC symbol. So this is 1 mark. DC symbol, positive, negative current supply. Now, explain why the soft iron pivots, making the striker hit the bell when the switch is closed. See, where is the iron pivot, iron striker, soft iron arm pivot, soft iron arm pivot. See, soft iron arm here. Okay, striker is here, and this is the contacts. Right now you can see this contact, they are not in touch with here. Okay, so what will be happening now? See, you explain why the soft iron pivots when making the striker hit the bell when the switch is closed. So this you must have the concept that so I will be writing that, okay, wait, let me tell you that when the switch is closed, so this is an electromagnet. So this solenoid or electromagnet is magnetized. Electromagnet is magnetized. When it will be magnetized, what it will do? This striker and this is iron. So iron is a soft magnetic material. It will be quickly attracted downward. When it will be attracted downward, so this striker will hit the metal plate, ball, metal gong or whatever, and the ring will be produced or bell will be produced. Okay, so what I'm going to do now, my dear friend, for first of all, as the switch is closed, closed mean turned on. I'm writing it here even. As the switch is closed or turned on, current flows through electromagnet, or you can say solenoid. Okay, let me write electromagnet. You may think later, sir, before you wrote electromagnet. So current flows through electromagnet, and electromagnet, we know it is a temporary magnet. electromagnet, and dear friends, it is magnetized, and then this electromagnet attracts the iron armature. So this electromagnet attracts what? Soft iron ore. Because iron is a soft magnetic material. Quickly it will be magnet. Soft iron arm. So when this soft iron arm will be attracted down, so you know this striker will hit the metal. So that's what, very simple. But of course, you must have the concept of this electricity. Now, explain why the arm pivots back to its original position after the striker hits the ball. Just think carefully. When this striker will come down, so what will happen here? The contact will be broken. Here, this contact, this is coming down, so this contact right now it is closed. Circuit is made, but when this will come down, the circuit is broken. When the circuit is broken, it means current will not flow through the electromagnet. It will be no more magnetized. So springy metal will bring it back. Springy metal will bring the striker or this iron arm back to its original position. That's what I'm going to write now. Circuit is broken and there will be no current. There will be no current in solenoid or in electromagnet. This is one mark, and the springy metal will springy metal, no need to write and, just new sentence we can write. Springy metal moves the soft iron, moves the soft iron back to its original position. Original position. This was 10 marks. Again, please let's see this again. My dear friends, here let's see this all. First of all, this switch is open. No current, this electromagnet is not magnetized. So this striker will be there and this iron armature will be upset. See, there is a gap now. So as the current is turned on, so this electromagnet becomes a magnet. It will attract the iron arm towards itself. When it will be coming down, the striker will be hitting the metal. This is the first 2 marks. But you just check. When this striker will come down, so this down contact, contacts are two. One is up, one is down. So this contact is attached to this iron arm. So this will also come down. Circuit will be broken. So as the circuit will be broken, so no current through this solenoid, it will be no more a magnet. So what will happen? This springy metal, due to its elasticity, it will bring back, or it will move the iron arm back to its original position. So that's what striker is going back after hitting this one. Okay, so these 2 points separately I have explained more. Even you can write in your simple words. Okay, my dear friends. Now next is, structure. Now describe the structure of nuclear physics question, structure of an atom of helium. So structure, it means we need to talk about not only the protons, neutrons and electrons, but also their position. So we can say 2He4 helium has 2 protons and 2 neutrons in the nucleus structure. So we have to tell where they are. Nucleus and 2 electrons are revolving the nucleus or around the nucleus. That's whatever you want to say. Sun is a medium-sized star. This was very simple. We did many times this sort of question. So Sun is a medium-sized star powered by nuclear fusion reaction which releases energy. State what happens during the nuclear fusion reaction which form helium. So, you can write the definition of fusion, and very simple definition, that is hydrogen nuclei. No, that would say 2 hydrogen nuclei, 2 hydrogen nuclei joined together. It should be joined together to make heavy nucleus of helium. That is more than enough for 2 marks, but even you can write at very high temperature. Also, you can write with release of energy. Even it is enough for 3 marks with release of too much energy. I am writing simply with release of energy. State 2 regions of electromagnetic spectrum by which the sun radiates most of its energy. Many times I discussed with you. One is infrared, mean thermal energy. Other one is visible light. Ultraviolet are there, but they said most of its energy. So infrared and visible light, my dear sons. Two marks. Describe what happens to a star when most of the fuel in its center has been converted to helium. So, then it is not the stable phase of the life of the star. So, what happens? So, center external force, pressure force decreases. So, in force of gravity increases. So, my dear friends, we can say the star expands. Just read the phases of the star expands and smaller star forms a red giant or there is another option in place of this, or we can write a massive star, big star, massive star forms a red supergiant in that case. So this is simply the life cycle of the stars. Easily you can read from there, but remember and score marks. These are free marks. This is simply a recall memory, my dear friends. Now, figure 10.1 shows the orbit of the Earth and the orbit of a comet around the Sun. State which orbit, A or B, is the orbit of a comet. We know orbit of a comet is elliptical. So, B. Explanation, you can say Sun is not at the center. This is one answer. Or orbit of comet is elliptical. That is also okay. Same meaning. Orbit of the comet is elliptical. Any one of these two options you can say. Describe and explain how the motion of the comet changes as it orbits the sun. It becomes faster when it gets closer to the sun, so its kinetic energy increases and potential energy what? That decreases. So we can write simply these 2 points. Now, first of all, my dear friend, that speed of comet increases as it moves closer to the sun because its gravitational potential energy decreasing. Closer to the sun, it means the comet gains kinetic energy, but gravitational potential energy of comet decreases, and this is now 100% according to the conservation of energy. So gains kinetic energy, but GPE of the comet decreases to conserve energy, my dear friends. That is simple. So now next is, at one position in its orbit, the comet is at this much light years from the Earth. So distance of the comet is given. State what is meaning of light year. Many times we discuss, recall memory. It is, and light year is not time. It is the distance, because it is the unit of distance for heavenly bodies which are very far from each other. So it is the distance traveled by light in free space. Light year in free space in how much time? In 1 year. So always remember this definition. Now determine the distance in meters between the comet and the Earth. Very simple. See, distance of 1 light year. That is first time, by the way. It is, many times we discussed, you have to memorize this number, 9.5 times 10 raised to power 15 meters. Now distance of this much light years. So distance of 6.6 times 10 raised to power minus 6 light years. So simply what we will do, my dear friends, we will multiply them. So 1 light year, first of all, 6.6 times 10 raised to power minus 6 times 9.5 times 10 raised to the power of 15. So we will multiply them together to get the answer. Distance of 1 light year, we know that we can calculate, even its calculation is for 4 marks even in exams. Very important. So now 9.5 times 10 raised to the power of 15 in meters times 6.6 times 10 raised to the power of minus 6. As I'm simplifying, I'm getting 6.27 times 10 raised to the power 10. So even we can round it off to two significant figures. I can write 6.3 times 10 raised to the power of 10 meters as the answer, my dear friends. So this is now the distance traveled between the comet and the Earth, my dear friends. So this was the last question of this paper. Mostly, one thing I would like to share with you people, observe that most of the paper is simply a recall memory, either the definitions or the rules or the equations and conversions. Very few conceptual questions are there. Conceptual questions were there in electricity, even waves, straightforward, not a big issue. So just memorize the formulas, the definitions, the rules, and practice a lot of papers, but within the given time. Any question you have, you can ask me now, or this video will be shared with you people. This recording will be shared with you people. Rewatch it. Any moment you find difficulty, ask me. I'm ready to answer. And inshallah, see you tomorrow, and we will be solving another paper. Thank you. Stay blessed, all of you. Take care, and assalamu alaikum.